The broadcast is now starting. All attendees are in listen-only mode.
Hello everybody and welcome to our session. We're just going to wait a few minutes more just to allow the later participants to join the session, and then we'll get underway. We'll be starting shortly. Thank you. Okay, I can see quite a few people have joined just in the past 60 seconds alone. So I'm just going to give it a couple more minutes to allow people logging in on the hour to join the session, and then we'll get underway. Hello everybody, and you're very welcome to this, our third MIDEL webcast in our technical series on electrical substation innovation. My name is Matthew Connaughton, Group Marketing Manager here at M&I Materials, and today we're joined by two Ester Transformer Fluid experts from the MIDEL team. They will be explaining the concept of upgrading in-service mineral oil-filled distribution transformers through what's known as transformer retrofilling. They will then take you through some technical case studies hand-picked for today's audience before fielding your questions about this topic. Our first presenter is Mr. Steve Jones, Sales Director for MIDEL in the Asia Pacific region. Steve leads the MIDEL APAC team from our hubs in Delhi, Shanghai, Brisbane, and from Singapore, where he's based. Steve has a wealth of experience from his tenure as EME Sales Director for MIDEL, notably serving public and private customers in the utilities and energy sectors, as well as developing partnerships with transformer OEMs and, pertinent to the process of retrofilling, leading electrical engineering service providers. Also joining us today is our esteemed colleague, Dr. Attila Gyure, who from a previous life is a former assistant professor at the University of Technology and Economics in Budapest. Dr. Gyure runs many research and development projects here at M&I Materials on the application of retrofilling in his role as one of our senior experts in the field of ester dielectric liquids. Dr. Gyure supports many MIDEL customers in their natural and synthetic application challenges. He's also a regular contributor to peer-reviewed papers published through international bodies such as the International Conference on Dielectric Liquids, or ICDL, CGRE, and IEEE. Before we begin, I'd just like to cover a couple of very brief housekeeping points. I have muted everybody on this call who's joined by computer audio, but if you've joined by telephone, please can you mute your microphone now. We will be fielding questions at the end of the session. If you would like to ask a question, you can do so at any time. Just check the little red arrow in the top right-hand corner of your screen, and that will open up the chat window, and you can put your questions in there. We'll be taking those questions in around 20 minutes or so. So, the introductions and those housekeeping points out of the way, that just leaves me to hand you over to Steve Jones. Steve.
Thank you, Matthew. And again, welcome everybody to the next episode of the MIDEL webcast series. It's a pleasure for me to be broadcasting to all of you from here in Singapore. As it was last week, fantastic to see so many large numbers of electrical industry professionals from all over the region joining us. Again, for those that are familiar with MIDEL and have been part of this webinar series, welcome back. And for those of you on this is your first interaction with our webinar program, welcome to the MIDEL Club. So as to serve as a quick reminder, MIDEL is a range of natural and synthetic ester transformer fluids, originally developed over 40 years ago. You may be more familiar with them being called vegetable oils, high fire point fluids, or K-class liquids. They all sit in this similar category. The word ester comes from its chemistry in the manufacturing process, which is short for esterification. What is important for you to note is that not all esters are the same. They normally split into two distinct groups, just how you can see them on the screen. We have synthetic ester, MIDEL 7131, made from organic compounds, and natural esters, MIDEL EN 1204 from rapeseed or canola, and MIDEL EN 1215 from soybean, and you may be familiar with other soybean natural esters. Each one differs in its performance and suitability for certain applications. For example, natural esters are not oxygen stable, and they shouldn't be used in breathing systems, whereas synthetic ester, MIDEL 7131, actually has better oxidation properties than mineral oil and hence can be used in all transformer types. For retrofilling, today's webinar topic, it is most common that synthetic ester, MIDEL 7131, is selected as the fluid of choice given its superior technical properties to others. It can also be handled in much the same way as mineral oil, which offers a benefit to maintenance crews and service companies as equipment and large parts of the process remain the same. All three MIDEL fluids are fire safe and environmentally friendly, and each have a long and well-established service history, even up to 400 kilovolt large power transformer. Electrical networks form a key part of enabling us to go about our daily lives. For years, these little grey boxes or tanks have been the backbone of our society and unsung heroes serving our industries. Quietly working away in the background, they go greatly unnoticed. That is until something goes wrong. A fire erupts, a community plunges into darkness, or an industrial area grinds to a halt. To consumers and stakeholders, this is unforgivable. The minimum expectation, certainly for most of the world, is that we can access electricity almost any time that we want to. Building on from that, our wants and needs as energy users are more demanding than ever before. Our networks need to work harder, and constraints around us start to creep in. Our collective challenge is that we continually find ways to keep that electricity available and use better materials and technologies in our transformers to build improved resilience and network performance in our existing assets. This not only to keep up with the demands of today, but also prepare us for well into the future. For an asset manager, we are to finally balance network availability, performance, and an aging fleet with challenging budgets and unhealthy transformers. Retrofilling with MIDEL gives us a fantastic new tool in our box, one that can extend transformer life, reduce operational risk, and upgrade performance with increased flexibility. There are many challenges that are faced when managing assets. Unfortunately, the networks and equipment that was once deemed adequate and compliant may no longer be the case. This environment is dynamic and as such constantly changing, and therefore so should the approach to managing it. All of the points listed on your screen will drive you to consider retrofilling with MIDEL. We'll take some time during this webinar to explain each one of those in detail and help you understand how you can overcome them. You could be forgiven for believing that any of those points only ever led to a decision to buy a new transformer, invest in expensive civil or other safety engineering measures, or to endlessly service the existing mineral oil time and time again. Retrofilling with MIDEL gives you that other option. So what is retrofilling? Okay, our definition is to simply replace the existing mineral oil in your transformers for MIDEL. There is no need to wait for new equipment lead times or the burden of complicated project construction phases. It can be done on site in a time-efficient manner. Retrofilling is not a new concept. It was first completed 41 years ago, 1979, on an arc furnace transformer in the United Kingdom. Since then, many thousands of transformers have been retrofilled with MIDEL around the world. As Ester experts, we publish guidance on how to competently complete a retrofill. We also work in partnership with leading transformer service companies under a scheme called MIDEL Service Partners, or MSP. This community of partners is well established across Asia Pacific, and you can contact us directly to find out more or for who can help you in your region. My colleague, Dr. Attila, will now take you through the technical properties and considerations to allow you to confidently introduce retrofilling to your transformer maintenance schemes, refits and upgrade programs. We will then return to see real examples of how others have acted and implemented MIDEL retrofilling as an appropriate and effective asset management strategy. Over to you, Attila.
Thank you, Steve. Welcome, everybody. On this session, I'd like to summarize some technical things regarding to the retrofilling, and I just used the same summarizing slide what I used the last time on the fire safety point of view, but now I just like to highlight a couple of properties from the retrofilling point of view. The first one, what Steve mentioned as well, about the fire safety of the liquids. And as you can see on the screen, the MIDEL has the classification as per K2 or K3, which means the fire point of these liquids is greater than 300 degrees C, and it has a low net calorific value, which means it cannot sustain the burning if things happened, and it has its self-extinguishing properties. The next one I'd like to highlight here, that is about the biodegradability. All MIDEL esters are fully or readily biodegradable, which means if there are any small leakage and things like this happens, or any drips, there won't be any harm on the environment, whereas unfortunately with mineral oil that is not the case. The next one, which could be sometimes an important point, is the moisture saturation of a liquid, like in a very humid environment and area. In this case, we need a liquid which can absorb and keep a high moisture level, and in this case you can see that mineral oil has around 55 ppm maximum water level at 20 degrees C. However, MIDES EN and MIDES 131 has higher numbers, like natural ester MIDEL EN 1100 ppm, which is around 20 times higher, or MIDES 131 of the synthetic ester is more than 2000 ppm, which is around 50 times higher. Steve mentioned something about the oxidation stability, and in this case, if you just see the numbers and compare the numbers to each other, you can see that the MIDEL EN natural esters have a lower number on this comparison, whereas mineral oil and MIDES 131 has higher numbers, and so that means the higher number means the better oxidation stability, which could lead us that natural esters are not always suitable to use in greasing transformers. That is why we always recommend please use in a sealed condition. MIDES 131 and the synthetic ester you can use both in sealed or free beading construction as well. The last one, what I just like to mention here about the pour points, you can see that natural esters have a low pour point, -80, -31. MIDES 131 has a really low point, -56, which is sometimes a little bit better than mineral oil. However, to compare the right picture, I would say that you need to see together with the viscosity values as well. If we see the viscosity, you can see that the ester liquids have higher viscosity than that of mineral oil, and this is why we always need to make some consideration before retrofilling what could be the outputs of this transformer from a thermal point of view. So on the next slides, I like to show you again at the fire safety videos, what maybe some of you watched last time. Just a very brief repeating on that, or just a refresh things that you can see on the top part, a pan filled with mineral oil, and there is an oxyacetylene torch which has a 3000 degrees C, which is just applied to the liquid, and it can heat up the liquid. And on the top left hand side you can see a mineral oil pan where this torch is heats up this liquid up to after 3 minutes to 95 degrees C, and unfortunately you can see some burning on the surface, and after 4 minutes all the pan and all the mineral oil just started burning, and we need to do some extra measure in this case. On the bottom part you can see the MIDEL Ester 131. In this one using the same 3000 degrees oxyacetylene torch, and after 3 minutes you can see that it's just like blowing the surface, and the temperature is around 100 degrees C of this liquid. After 70 minutes, which is an hour and 10 minutes later, you can see that the temperature increased to 230 degrees C. However, the surface is just blowing again, and you can see some small sparks. However, due to the self-extinguishing properties of this liquid, it's very hard to get a full ignition, and that is why we always say it's very hard to ignite. On the next slide, I just like to compare these liquids from a biodegradation point of view. During this kind of test, as per the OECD 301, they collected an amount of bacteria from CO, and they put this into the liquid, and after that either they can measure the consumed oxygen of this environment or of the bacteria, or they measure the produced CO2 of these bacteria during the test of this 28 days test. And after that, using these numbers, they are able to convert what we call the biodegradation rate. On this screen and on this curve, you can see that natural ester, after the 28 days, it can achieve the value of the biodegradation rate of 95 degrees C, sorry, 95%, which means that the 95% of the liquids that is, we can say this, or we can say that was eaten by the bacteria from the soil, and only 5% is remaining in the soil in this case. Whereas comparison like to mineral oil, you can see that these values can achieve, let's say, 10% after 28 days, which means only this 10% can be eaten by the bacteria. However, the 90% just remaining on the soil. That is why we always need or should replace the soil after a big spillage of mineral oil. To get the fully already biodegradation classification, the liquids needs to be achieved at least 60 or 70% of the biodegradation rate, and that is the threshold to get this classification. On the next slide, I'd like to show you a couple of things on the moisture saturation of this kind of liquids. As I showed you on the comparison side, maybe you remember that these liquids has very high saturation value, like natural ester 1100 ppm and 20 degrees C, or MIDEL Ester 131 as a synthetic ester at 2700 ppm at 20 degrees C. And these high moisture saturation value can be achieved without changing or dramatically changing the dielectric properties of these ester liquids. And this is a good point. That is why we can use these high values. The other thing of the ester liquids is that they always would like to collect this moisture and keep this moisture. And if it's inside the transformer, that means it would like to collect this moisture from the transformer, from inside the materials, like from the cellulose. And at the same time, that means the cellulose or solid material will be drier if they use the ester liquid. And as we know that if the cellulose material is drier, that means the lifetime of the cellulose will be longer, and at the end, the lifetime of the transformer will be longer. If we see like the other points of view of these liquids, like the higher operation temperature, it's possible, as Steve mentioned earlier. Due to the higher fire point and due to the higher flash points, we are able to increase the operation temperature of these transformers. In other words, that could mean that there will be a higher chance to get a better overload capability or overload resistance in this case. And altogether, if you just put together all these small bits and pieces, we can say that there is a high chance that we are able to extend the lifetime of the transformer if somebody uses the ester liquids. And that could happen in the same case if we using the retrofilling as well. If we just go to the next slide, we can see that on the technical considerations, what we need to just think about that before starting anything. So in this case, we can say that from the construction point of view, the distribution transformer up to 33 kV, we haven't seen any issues to carry out any retrofilling. If the transformer's voltage level is higher than 33 kV, or with us, that's just please call us as a MIDEL technical team, and we can discuss what could be the options in this case. The next point, which is just mentioned, like miscibility guidance. We know that, and in the past that was proven, that MIDEL ester liquids, both natural and citric esters, are miscible with mineral oil. There is no any issue. There won't be two layers after the mixing these liquids. So we can say that yes, MIDEL ester liquids are miscible with mineral oil. However, if you would like, or somebody would like to retrofill a silicone-filled transformer, we would say it's not the best option, because silicone liquid is not miscible either with ester liquids or mineral oil. If you try to do that, I'm sure somebody just tried that, you will see that there will be some foaming effects, and we always like to avoid these kind of things. So the point is here that MIDEL ester liquids are miscible with mineral oil. The next point I just put here, the on-load tap changers. If these kind of tap changers, it's a vacuum type tap changers, there is no issue. If these kind of tap changers is a oil type tap changers, yes, we need to look at closer what is possible, or what we need to, or you need to change in this case. On the transformer point of view, we need to check, of course, the transformer. If you just go back, sorry, I just put. If you just go back to the previous slide, yes, here. In this case, we need to check the transformer itself. Many times it is gone through via the DGA testing. If it's possible, we always ask at least 2 results prior to the retrofilling to get some picture about the transformer construction or the condition. If it's possible, we ask to get some field analysis to get some indication about the paper condition. And after that, now we can go to the next slide, where I'd like to show you the process itself. The first thing is that, of course, drain the liquid from the transformer, like the mineral oil in this case. And after that, if it's possible, please wait a short time to get some drip down all the droplets from the wall, from the windings, from the other internal construction. And after that, the step 2, I think that is one of the most important steps. That is what we call the rinse, or in other words, please do a hot flush with fresh new MIDEL, which means that after you drain out all the mineral oil, waiting a little bit time, and after, if you are able to open the lids or the mineral oil on the side, please to rinse or do a hot flush with MIDEL in order to just like a washing time or the internal construction parts with this new MIDEL. Many times we would say that these additional MIDEL would mean around 5 to 10% of the whole volume. So that could give us a really good results at the end. On steps number 3, that is just stripping down, we just wait to strip down all the mixture from inside of the transformer, and after that, if it decided that everything is fine, we are able to refill this transformer tank with a brand new fresh MIDEL, which could be, of course, synthetic ester and true ester as well. And as a step 5, we need to create some tests. And from the transformer point of view, of course, we need to check whether there is any leaks or not. Many times it's possible to carry out the Megger test or the DC test or the insulation resistance test. That is what you call. But bear in mind that if you carry out this Megger test, you will get a much lower value than you have with mineral oil. In case of ester liquids, you will get a 1/5 or 1/10 lower value than you get mineral oil. That is true for all kind of ester liquids. If you measure like the thunderata of the transformer, in this case you will get a little bit higher, sometimes double number than you get with the mineral oil. And again, that is due to the chemistry of the ester liquids. There is no any issue with that. Everything is perfectly fine. Just please be aware of that. And if everything is okay, and after the refilling, you do all that job, change the cartridges, change the filters, all the things. After that, you are able to energize the transformers and bring on load. So now I'd like to just hand over back to Steve, and he will show you some case studies.
Okay, thank you. Thank you very much, Attila. Just before we do go on to the case studies, which give some excellent insight into the practical implementation, it's worth just spending a few moments to take a look at what makes a good candidate for retrofilling. So you've now seen the key performance criteria. We've introduced some technical considerations and walked you through the main steps of the retrofilling process. So we can now use that knowledge to help us identify what does make a good or suitable candidate for retrofilling with MIDEL. So think about your own transformers, and are any of these scenarios familiar? Do they seem familiar to you? Do you have transformers that are wet and continually need drying operations carrying out as their breakdown voltage falls below the required minimum? Does your substation or transformer installation still comply with regulation and guidance? The built environment around the transformers, it may have evolved since it was commissioned and requirements become more stringent. What options do you have available? Has the recent audit or inspection taken place in which a mineral oil transformer is considered too risky and recommendations put forward to introduce a K-class fluid such as MIDEL? In this case, retrofill would be the most cost-effective way of reducing that risk. Are your transformers exposed to creating environmental harm or pollution in the instance of a leak or spill? You may want to consider looking first at assets near to a watercourse to reduce your impact to our environment. Are the transformers in close proximity to people or to property? How would you risk assess fire safety on the current installation? And then what steps can we take to prevent fires in the future? We of course covered this topic in a lot of detail during last week's webcast. A growing trend is that organisations making policy decisions to embrace safer, greener technologies that are more sustainable, such as MIDEL, which can then have a profound impact on their social responsibility. Do we need to do more with the equipment we've already got? Our CapEx budgets may be restricted or reduced, so we need to find a way to extend the life of existing transformers to help the financial planning process. There are not many materials available that can extend the life of a transformer, but MIDEL can. It may be that we have a particular vulnerable asset or assets, a number of them, which are frequently subjected to a state of overloading. Here we have major problems with reduction of life and of course fire safety. MIDEL offers a more flexible and safe overload profile without greatly reducing life as it would in mineral oil. It's common knowledge that an increase in temperature of around 6 degrees in mineral oil could reduce the life of the transformer by half. If we consider the IEC standards, with MIDEL, we can go 15 degrees hotter for the same life. That's a huge benefit. So look, I'm sure, I'm very confident, and certainly from conversations I have with industry, these scenarios play out every day. You now have a fantastic solution to help manage them, and that is MIDEL retrofilling. So I promised we would take a look at some case studies. So let's move on to that. So here we have operators who faced some of the challenges that we've just explored, and then we'll understand the benefits they realized from a MIDEL implementation. So for our first case study, we traveled to Central Europe, an implementation program that started almost 30 years ago now in 1992. In the beautiful city of Berlin, you'll find many waterways that became classed as water protection zones. Mineral oil filled transformers pose significant environmental risk, and as such, a new approach was needed. MIDEL 7131 was chosen as a way to mitigate that risk, and since then, over 5,000 transformers have been retrofilled in this city alone. As part of this wide study, world-class utility Vattenfall also evaluated what happened to both the moisture content and its relationship to electrical strength, here recognized as breakdown voltage, over a long 13-year period. You can see on screen that the blue line steadily increases. This is because of the polar nature of the ester slowly migrating the moisture from the solid insulation to the fluid. At the same time, we are significantly slowing down the aging process. MIDEL can handle moisture much better than mineral oil, and this is shown on the yellow line, in that breakdown voltage was almost completely unaffected over the 13-year assessment. It remained electrically strong throughout. Vattenfall is a good example of a utility that uses MIDEL in various elements of its network strategy. Both new and existing transformers in the traditional utility network are included, as well as its hydroelectric plants. So from Central Europe, we now head to the Indian subcontinent, to the east, and the bustling city of Calcutta. This immediate district had the operational responsibility of supplying 2 million customers. They had also been trusted with the moral responsibility of ensuring the transformers were safe, especially given the proximity to factories, homes, and schools. They took the preventative step to protect what matters most and began retrofilling transformers from mineral oil to MIDEL 7131 and felt that the K-class performance gave them the peace of mind that safety was assured. Projects like this one have since been replicated in the megacities of Delhi, Mumbai and Chennai, making India's networks much safer and capable of better performance. Let's now move into the Southern Hemisphere, where we encounter a mine in Australia at Mount Isa, one of the world's largest zinc mines. Distribution transformers that were originally above ground were to be relocated underground. The electrical superintendents were very concerned about the risk of fire and then smoke in a confined space. This would make a safe evacuation of people almost impossible. To mitigate both concerns, the transformers were retrofilled with MIDEL. Recognizing the benefit in their existing fleet, the operator then acted quickly to change the specification of a new substation from mineral oil to MIDEL. Retrofilling with MIDEL is rapidly becoming best practice for mining operations as pressures to increase safety in above and below ground installations increase. Staying in Australia, we head to Ergon Energy's Comet substation. Whilst the utility recognised the benefits of fire safety and the preservation of the solid insulation, which we've explained, a key driver on this project was purely economic. To continue using mineral oil on this substation, they would have had to expand the site and install large oil containment. The introduction of MIDEL through retrofilling allowed for a simplified earthen bund arrangement that resulted in a saving of $500,000. This great example can also be found on YouTube, where all of the benefits realized are explained in detail by the utility. To do it its full justice, I encourage you all to watch it. It can be found under the search term Hello Comet on the YouTube homepage. So again, we covered a lot in a short space of time. And I would just like to leave you with 3 notes to take down if you have a pen available. And one is, retrofilling works. It's simple, cost-effective, and proven. Embrace the material science. We shouldn't only invest in digitization and better monitoring, but tackle the problems that need the additional monitoring requirement. 2, think technology leapfrogging, now a common concept. Existing equipment doesn't need to be neglected and void of the current best practices. Leapfrog the traditional mineral oil and upgrade performance with MIDEL. And number 3, future-proof your networks. The decisions you make now will make a big difference on how successful your asset management strategies will be. In a short space of time, the future energy network will look very different to today. Those that implement better materials into their transformers now will be rewarded with a more accommodating and flexible electrical infrastructure moving forward. One that is capable of managing greater energy density, integration of renewables, and emerging trends such as IoT and electric vehicles.
Thank you, Steve, and thank you, Attila. That's all we've got time for today. We will go into questions now. We have a lot of people still in the room with us, so we'll move on to those. First one, Attila, perhaps this is for you. how much of the residual oil can be mixed with MIDEL before the asset is energized again after a retrofill? So this speaks to miscibility thresholds.
Thank you, Matthew. In this case, I would say that we need to distinguish between the two ester liquid. If we are able to follow the process of what I showed you, in this case with synthetic ester -131, if the mineral oil content is less than 3.5%, in this case we are on the safe side. In case of natural ester like MIDEL liquids, these values should be around less than 7%.
Thank you. Second question, perhaps for yourself, Steve. I think you covered this at the start briefly. How established is the retrofilling process, and are there more references we can read about?
Great question. We would believe very well established. Okay, that MIDEL was originally introduced as a retrofill solution against harmful substances around. And since then, we've seen many thousands of MIDEL retrofills around the world. Testament to its success is that often operators, once they've done one or two, then start to do more and more retrofills around their network as they understand the technology better. It is important, of course, that you do either follow our own guidance or work with one of our MIDEL service partners to ensure that the reliability and asset performance can be realized. There are also some more fantastic case study material on our midel.com website, which continually gets updated as more and more retrofills take place every single week.
Thank you, Steve, and great plug for the website there as well. We're just conscious of time, so I'll take one more question. Again, this is for you, Attila. What is the voltage limitations for retrofilling? I have heard of 69 kV before today, and you've talked about a limit of 33 kV.
Yes. Oh, yes. Thank you, Matthew. Yeah. So I told you that below than 33 kV, we haven't seen any issue with the construction of the transformer, like a distribution transformer. So that is why we say yes, up to 33 kV, it looks everything's fine from a technical point of view. Above this, or up to 69, you mentioned 69. This range, I would say, many times they are okay. A couple of times you need to check some extra things. That would be like, for example, the on-road exchangers, or checking the bushings and other kind of accessories. And so yes, many times it's capable up to 69 kV, but it's much better if we have a conversation on that, and later on we are able to decide together.
Okay, thank you, Attila, and thank you, Steve. Thank you both for your contributions today. That is all we've got time for today. We have captured everybody's questions on the session, and we will get back to you within 24 hours with a direct reply if there's something we've not got to. So I can see a number of questions we've not had time to cover today. If you would like to get in touch with our panelists yourselves, please feel free to contact them, and they'll reply to you directly with any questions that you might have about retrofilling or MIDEL fluids. I've left their details on the screen if you want to take those down. That is where we must draw this session to a close. Thank you very much for joining us today. This is a webinar which is part of a wider series. So later on today, in about 9 hours and 15 minutes or so, this session will be run again with slightly different case studies, different presenters. So if you've got colleagues on a different time zone, please send them to the MIDEL website where they can register for that. Concluding this session will be our Designing Out Substation Costs webinar, which is on Thursday. And again, that takes place same time zones, beginning of the day for us in the UK, and then later on. And that will wrap up this Substation Innovation series. Thank you very much for your time today. We hope you found that useful. We'll close this webinar now. We'll see you soon. Stay safe.